Welcome back. Today we're going to do something kind of special. So I'm not really going to introduce a new concept today. What I'm going to do instead is something that previous students have found to be very helpful. And that is, okay, you're about halfway through a relatively complex programming course and you've begun to learn a lot of techniques. It gets pretty tricky to kind of get all these things sort of put together, right? And so sometimes one of the most useful things to do is you say, okay, I think I know all of the stuff I need to do, but I don't really know ever how to get started or how to do the next step or exactly how to think through an entire project. So here's what I'm going to do today for you. I'm going to do what's called a live coding exercise. And that means I'm going to do a variation of a project you've already done. I'm going to change it up a little bit for a couple of reasons. One, to illustrate some more advanced features that you'll be using soon, especially heap management. And then secondly, just so that you can see how an experienced programmer would solve the problem you solved. So we're going to do the object-oriented horse race, and I'm going to do it slightly differently. I'm going to put everything on the heap. And so first thing to note is that if you just take all the code that I write here and you turn it in as your horse race assignment, you will get a 0. This is not what this is for. I'm doing it differently on purpose, so this code will not be useful for that. Instead, I want you to compare maybe the way you've already solved this problem twice. Now you look at it a third time and compare the way that an experienced programmer solves the problem to perhaps the way that you solved it and see. Certainly there's probably things I could learn from you, but I think you'll also learn some things from me. And I'm hopeful that I actually make mistakes. If not, I may have to introduce some so you can see how I respond to those errors, because that totally happens. You notice something very interesting is that the very first page that I have open in front of you is not Vim. It is a drawing program. It is a diagramming program. You might think that I'm just being dumb, but here's the deal. Really, I truly, truly believe it, that if you plan well, you've solved half the problem, maybe more than half. So we're going to begin with a quick UML of what we're imagining. And if I design that well, then the rest of this thing is going to fit together just fine. If I design it poorly, then I'll have a lot of problems. So especially in an object-oriented program, the very first thing you do is you think through the UML. And so I'm going to do a slightly different UML than you did, just because I want to look at things a bit differently. So the first thing I'm going to think about is what classes I want. I still want to have a horse class, and I want to have a race class. I think that'll be good. And then when we think about our objects, then you also think about their data members, and you think about their methods. And so that makes a lot of sense. A lot of times it's easiest to start with the object that has the fewest dependencies. That's an idea that's going to come back. So what I mean by that is this. I can do the horse without the race, but I can't really do the race without the horse, right? And I may even want a main. That's actually not going to be a class in this case, although it could be. I think I'm just going to have a main function. Okay, so now that we've got these ideas, let's think about what we want them to actually have. So for the horse, I think what I'm going to do is I'm going to make a private entity position. So really all the horse is a wrapper around this position, and that says where the horse is on the track. Okay, so that seems pretty straightforward. You've probably done something like that. Now we'll think of its public methods. And I can think of 3 methods that I would like to have, and maybe you would think of more or less, but let's think of the things the horse should be able to do. I think there should be an advance method, right? And that's gonna just be null. There should be a print lane method. So that may be different than how you did it before. You may have had print lane belong to the race, and there's some reasons for that. This time I'm going to have it belong to the horse just because I think that's interesting, and it will change a couple of things about how I think about things. So I have a print lane, so the horse will know how to print its own lane. And then I think I want to have an is winner, which is going to return a Boolean. I don't normally specify the type of data that a function returns if it's going to be null, but if it's going to return a Boolean, I would say that. Okay, now let's see about this, or void. Let's also think about this. I'm going to add a constructor, I think. I think it's going to be pretty simple. Now, the horse has only one piece of data, and I don't see any reason to have that on the heap. So the horse won't need a destructor. I am going to be doing some heap work later, but typically I don't put primitive values like characters and ints on the heap. There, you just don't really get a lot of, you don't get a lot of bang for the buck on that. Now, before I move on from this, we need to think a little bit about these things. So the advance function, does that need any more information that I might not have? Not really. The advance is simply going to take, it's gonna just move the position up one or not, right? So that one isn't gonna need more data. But the print lane, when we think about the print lane, and at this point you might actually start writing the algorithm down to figure out the print lane. Well, the print lane needs two pieces of information that the horse may not have. So the horse itself, now we could make this so the horse knows these things. That would be one solution. Or we could pass them as parameters. But it seems like there's two pieces of data the horse needs to know. One is its own number, and another one is the length of the racetrack. So there's a couple ways we could do that. We could change the constructor so it takes those things, or we could simply pass them in as parameters when we need them. Either is perfectly fine solution. I think I'm going to go ahead and just pass them in as parameters because that's easy. So that means that print lane will take two integer parameters. I want an int length of the track, we'll say, that'd be good, and an int horse number. Okay, let's make this look better because making things look good usually does pay off, doesn't it? At least making it orderly is helpful because this is going to be the key to me doing everything else. If I understand these things, we think about is winner. The way that is winner is going to work, it's going to return a Boolean value determining if this horse has won the race. Does that make sense? Okay, so let's give that the same parameters, I think. Now, could I be wrong? Yes, I'm guessing here, but I'm guessing in a clever way, right? I need to know the length of the race because that's when we've won. And do I need to know the horse number? I think just because I'm going to print out, hey, horse number, whatever wins. Now, I could have designed this in an entirely different way. I could have designed it so that whenever we create a horse, it knows the length and the horse num, and that would have been fine. You could argue that might have been a better design. But I'm fine with this. The problem is these two pieces of data kind of belong more to the race. So we'll just have the race pass them to the horse when we need them. I like this. This horse looks good. Now, typically, you could stop right here and make the H file for the horse, but I think what I'm going to do is I'm going to finish my thinking to make sure I understand what data belongs to the race, because then I think that's going to be probably a whole, I'll be able to see the whole picture when I have both of these classes kind of defined. So let's think now about the race. It's going to be a little bit different in its design because I think what I'm going to have here is it is going to have a horse pointer. It's not going to have a horse. It's going to have an array of horses. It's essentially a horse pointer. Because what I'm going to do is I'm going to this time create an array of horses on the heap. And so this is a pretty big difference than how you may have designed it before. When I'm creating data explicitly to go on the heap, then my attribute isn't necessarily going to be instances of that class, but pointers to that class. And this one is a pointer in a couple ways. It's a pointer because it's an array and we haven't determined the size of the array. Also, the elements of that array are going to go on the heap. So the array itself will go on the heap, and so will its elements, which is really in C++ the same thing. All right, so that's good. What else do I need? I think I need some constants, right? The length of the race would be a good constant. Okay, so let's call that const length. I like to capitalize my constants so I know what they are. I don't care what the starting value is, but that's going to be a const int. Okay, and now let's do another one, a constant, and this one will be the number of horses. Oh, what are you doing down there? Get back up there. All right, I don't know what that was trying to do. You could get cute and save a few characters, but I think honestly having your code clear is probably more useful than having it short. So I like my code to be nice and clear. Okay, I think that's pretty good. And the nice thing is, because we're going to be storing the horse array on the heap now, the number of horses actually doesn't have to be an array. That could be changed dynamically. I think I still won't, but we could. Okay, now let's think about its methods. And I think, honestly, I'm only going to have 3. And 2 of them are going to be obvious. First of all, I'm going to have the race constructor. And that may do some cleanup. I'm going to take no parameters because I don't see a reason for it to. So that we'll have a race constructor. Now, the race is going to create the horses on the heap. So what else do I need? I need a destructor. Okay, so we'll make a race destructor. And it almost writes itself, right? We know what's going to go there. Since we're going to be creating the array of horses in the constructor, then we're going to be deleting them in the destructor. Remember, deleting doesn't delete the pointers, it deletes the thing the pointers are pointing to. And then I need one more method, which I'm calling start, but it really is basically run the race. So we'll just say start. And now I look back at these and see, do I need any more information? Could I make my entire program work with just this data design? And as I'm looking at it, I could be wrong, but I think everything we need is right here on this diagram. So honestly, half of our program is written by designing this. Do you see how many decisions that I made before I even decided what programming language I was in? Yeah. And so now let's go through the process of trying to flesh this thing out. So now, fine, I'm going to take this and move it to my other monitor. And okay, oh, so all right, so clear. There we go. See, I'm gonna make a new directory, mkdir horse, cd horse. What's the first thing you do? Get init. Crazy to wait for get until later, right? We want to go ahead and make that a part of our process. I don't have anything to commit yet, but we'll go ahead and make this a new fresh Git repository because that could be helpful for us. And now we're going to think through our first thing. So I think the first thing I want to do is I'm looking at my my class, my most basic class here, and that would be maybe the horse class. Or maybe we would start with main. You want to start with main? I'm fine with that. Okay, let's start with main. Sometimes, especially when I've been switching languages, I'll start with main because here's what I want to do. Vim main.cpp. I just want to remember, oh my goodness, what language am I in, right? How do I just do a hello world? So a lot of times, even my most complex programs will start out as a plain old hello world. So we'll do that. Insert, pound include, IO stream. Okay. Main, standard cout. One day I will horse race. Is this just a horrible waste of time to write a line of code that you know you're going to delete? Oh, it's wonderful. Because see, the typing code is not what takes you time. Trying to figure out what the heck went wrong with your life, right? The sum total of your life choices that led you to this moment. That's what spends most of your time, right? So typing isn't the thing that you want to save time on. You want to save time by thinking well and by making sure that you've tested every step as far as you can. So I'm even going to test the most basic thing, which is, do I even remember how to write and compile C++ code? It seems crazy, but when you're a beginner like I am, and I've been a beginner for about 25 years, then it's not a bad idea to just check these things. Let's see, did I save it in the right place? I'll compile it one time by hand. Just to see if it works. Okay. All right, one day I will be a horse race. Okay, that makes me feel good. But before I go any farther, that's the last time I'm going to compile by hand. Let me go ahead and start building my tooling, which would be the make file. Now, this is interesting. A lot of you, I see you actually sometimes waiting, thinking, well, I can't make the make file until I have all of my other files in place. Because you're thinking you do that as one step. And I'm saying, no, the make file changes as your project changes. So every time I add a new file or I rethink things, I also want to rethink my tooling. That's the easiest way to make the make file, is to actually have it sort of iterate through your process. Especially because we'll be using Git, right? And throughout the Git process, we can back up, and looking at the make file at any step tells you what you were thinking the whole thing was doing. So it's not a bad idea. So I already know what my final target is going to be when this whole thing is done. The horse race. And for now, all that needs is main.cpp. And you're like, what about my O files? What about, stop, we don't care. We don't need that yet. All right, we're going to change this when we need that stuff. So right now, we just need the command for getting there, G++, oops, G++. I'm going to go ahead and say -G because I know I'm going to eventually need the debugger. Main.cpp. Will we change this? Sure we will. Okay, that looks pretty great. While we're at it, let's go ahead and make the other ones we know we'll need, right? Run requires horse race. Okay, and that's just /horse race. Let's do a debug. Also requires horse race. And that's going to be gdb horse race. Wow, what a pessimist. I already think I'm going to need the debugger. Oh, I'm sure of it. Yeah. We could do a val grind now. I might wait until we actually need it, but okay, so that's good. You want to clean? Sure, we'll do a clean. Clean typically has no dependencies because you could always clean. And we'll say rm star.o, which there won't be any, and rm horse race. That's just nice to have. Okay, make clean. It complains there were no .o files. That's fine. Make run. That should recompile. Ooh, did it? Okay. So make run, and it ran. Okay, so now I'm feeling pretty good that I have my general tooling ready to go, and I can start modifying that as I need. If I want, I can go ahead and do a commit, right? There's nothing wrong with that. Git add dot git commit -m initial commit. Now at least I know that. Now, if you're going to be standing up and leaving, then you may also want to go ahead and send it out to your remote server. I'm probably not going to put this on a server anywhere because I'm going to throw it away when we're done. Okay, but that tells me where we are. That's pretty great. Now, I think the next thing to do, look back at my diagram, I think we're ready to build our horse. And we're going to begin with the header file because this diagram essentially is the header file. Really, when you look at it, everything I need to know is right here. So I'm going to move it to my other monitor, and we're going to make a horse.h, and let's see what this thing looks like. All right. Where'd it go? Okay. So vim horse.h. Okay, I'm a little scared, but you don't have to be scared because you know header files have a pretty standard pattern. We're going to start with the if and def business, right? So if and def horse h exists. That's a good name for that token. Then if that does not exist, then I'm stop. Then I'm going to define horse h exists. And then somewhere at the end, I'm going to do an end if. That's just pretty much automatic when you're building a header file, right? Now I want to think about the horse class. It's going to be a class. Because I now know something about inheritance, I'm going to go ahead and make my position protected rather than private. What's the difference? Well, if you remember, private means nobody else can ever see this. Protected means if I ever subclass this, my subclasses can see it. I don't expect to need that, but typically I make things protected because generally I think subclasses will need access to this. So I'm going to go ahead and make this a protected data member. Int position. Don't think it needs anything else. I think that should be fine. Now let's take a look at what my public members are. Generally, those are going to be your methods. Let's see. I said I wanted a constructor, right? So we'll do horse. I'm just looking over at my diagram, right? I'm not guessing here. That's the beautiful thing, is that my diagram is telling me exactly what I need. Do I need a destructor? No, it says I don't need that. But I do want an advanced method. And at this point, I know I don't think I'm going to need any parameters, so I'm going to leave it like that. Now think about what it returns, though. That's going to return a void. Okay, that's good. And now we'll want a print lane. I think that's also going to return a void. Void print lane. This one we decided we want to have some parameters, right? Int length, int horse num. Oh, num. Okay, that looks good. And I think we want this Boolean is winner. I like that idea. Now there are other good solutions. Oh, not void. Boolean is winner. Int length horse num. What if you didn't anticipate, like I did, that you'll need this data? And then you're like paralyzed. No, don't be paralyzed. Go ahead and do it the way you think is right. And at some point you realize as you're trying to do the algorithm, hey, I can't do this. I'm missing data. Then change your diagram. Then change your header. Then change your code. Don't go the other direction. The documentation drives the code, not code driving the documentation. That's really, really key. If you learn that, you're going to be in great shape. Okay, and why can I say that? Well, because I confidently am expecting to be able to write a program that took you how long? I'm going to write it in about an hour, beginning to end, because I'm confident. I'm confident that if I design it well, I should be able to build it. All right, that looks like a pretty good horse class. I like that. I'm going to go ahead and save that. Let me show you a really cool Vim trick. Escape : V split. That makes a vertical split in your screen. And now Control W switches, which is really neat, between the two panels. And I can do an E horse.cpp. And that'll create a new file over on the other panel where I can actually build the CPP file. And it's really nice to look at the H file while you're building the CPP so you remember what you need, right? That's exactly what I'm doing. Again, I can just do it from the diagram because the header file is just another way of saying the diagram, isn't it? Yeah, it's really the same stuff. So let's start to flesh this thing out. We'll think about some dependencies we're going to need, right? So we'll go with the ones we know, right? And I think the first thing I'm going to need is pound include horse.h. Now notice carefully, horse.h is in quotes, double quotes, because it is not a system file. It belongs to me. So I'm going to be reading from my own directory as a default. Okay, and let's see what else we need. I don't know if we'll need a string streamer or anything like that. I know we'll need IO stream. I think we will. So let's go ahead and do that. I think we'll need that. And that also gives us string. So we may need other things, but we'll add them as we need them. And it's okay if you don't really know. So, all right, so let's think about this. Now we have to start creating these methods, right? So let's see, horse, that's going to be the constructor. It takes no parameters. And what are we going to do? We're going to say horse position gets 0. So when we first build the horse, its position is going to be 0. And how do I know that? Well, if you're ever in doubt, right, remember constructors always initialize your data members. Maybe it does other things too, but that for sure it's going to do. This doesn't need a return type because it's a constructor. I don't need a destructor, so I can start talking about horse advance. Now at this point, I would actually write out my algorithm. Since you've done this before, this particular thing, you probably already know what the algorithm is going to be, right? But I'll go ahead and do it in this case. Roll a random integer. Or yeah, roll a, or flip a coin is what I'll do. Flip random coin, move 1, not 0. Okay, this implies a couple of things. One, that we've done an srand somewhere. I'm gonna not worry about that yet because the horse doesn't need to worry about that. But I do need to think about this. As soon as I said the word random, well, what library should I probably bring in? You might have to look this up. There is that marvelous random function, but it's in the C standard library. So include C standard lib. If you don't know that, you just look on the documentation. You try to compile it once and it says, I don't know where this is. And then you go c++.com or wherever and say, oh yeah, random came from the C standard library. No problem. Okay. So now I think I can do it. I can do something like this. Int coin gets rand modulus 2. That's going to give me a 0 or 1 because I know the rand function is going to give me a large integer. Mod 2 is going to always give me a 0 or a 1. And now I'm just going to say horse position plus equal coin. There are other ways to do this with if statements and so on, but if I already know the value is a 0 or 1, when it's a 0, add nothing. When it's a 1, add 1. Oh, that's elegant. Sometimes you'll see elegant solutions. Sometimes you'll just kind of hack through. It's fine. Just get it working. Get it working. But if you can see a pretty elegant solution, by all means, do it. Okay, that's surprisingly easy. Okay, let's do the print lane. And actually, I kind of like doing it this way because now I know all the data is there. I'm going to say it takes a length and it takes a horse num. Okay. Now I think this can be self-contained. So that's a beautiful thing is right here. I can now have it do whatever I want. And again, you've seen the algorithm for this, right? And there's a couple of ways you could do it. But for each position on the track is my position that if I'm at that position, print my number, otherwise print a dot. Okay, with that algorithm, I should be in good shape. I think that's going to work. Now we just have to convert each of these lines of algorithm to C++ code. For int p gets 0, p is less than length, p plus plus, I think that's going to work, p for position, right? Okay. If horse colon position, so my position is equal to p. Oh, what language am I in? Conditions have to be. See how worried I was there? Not. Okay. All right. Print my number. Okay. Standard cout my number. Position is my number. I could say horse position. It's the same. Okay. Otherwise, well, that's else. Printed dot. Okay. Standard cout. Okay. You love how I'm labeling everything as I end it? Yeah, making my life easier. I think these are going to just go in line, so I want to have an end line at the end. So after the for loop is over, see how nice it is to be able to tell what's what. And in Vim, you can also move over a brace and figure out, it'll show you its partner. So that's pretty handy. Okay, so now I think after the for loop is over, I've gone through every position. So now print a new line. So standard cout. Sorry. Cout standard handle. I think that's going to be pretty good. That will print one lane for one horse. Some of you got really tied up in this because you wanted to make your function do too much. I like to have a function that does as simple a thing as I could have it do and do that thing well. So I'm going to have one horse print its lane in this function. And if I want to do that with multiple horses, I'll do that elsewhere. So you want to have one function do as simple a thing as it possibly can. Now you could find it pretty annoying to have all of this comments here. And if you do, just put them in a separate file. And typically I would. I think it's getting a little wordy. But as a beginner, if you want to have the comments right there, I'm perfectly good with that. Okay, so check, we've done the constructor. Check, we've done the advanced. Check, we've done the print lane. Now we'll do the is winner. Okay. Horse is winner. That I've decided is also going to take an integer for the length and an integer for horse num. That seems to make sense. And now we'll think about this. What is our algorithm for this? Well, we're going to say if this horse's position is greater than length, return true. Maybe we'll do this. Print horse num and return true. Otherwise, just return false. Now, you can have multiple return statements. I think it's generally a bad idea. And the reason for that is that really you only need one exit condition. So there's a slightly better way we could do this. I'm going to do this. I'm going to say bool is winner gets false. So I'm going to say we're going to have a Boolean that tells me if there is a winner. And we're going to start it out as false. Now we could do this. We almost can't, I mean, the algorithm is almost code, isn't it? If horse position, or since there's no ambiguity, I can just say position. If position is larger than, maybe larger than or equal to, we'll try that. We could be wrong on these things. How much is that going to bother us? Not. Okay. Okay, so standard cout horse number horse num wins. What about time? I'm not going to worry my pretty little head about that right now. That's what about time. Standard cout. How many problems do you solve at once? One. Solve one problem at a time. All right, now I'm starting to run. Having these side by side is starting to get in my way a little bit, but that's okay. And we'll set is winner. Yeah, I'm going to do that down here. I've put my code underneath the comment. I'll do it again. Winner gets true. So winner was false, now it's true. Really, do I need to do anything else in this case? Because it'll already be false. So here's the sweet thing. I don't really need to do an else clause here. But I do need to now return, not winner, is winner. You were yelling at me, weren't you? Okay, now I'm going to return is winner. So I'll only have one return statement, but that return statement will contain the is winner. All right, that looks pretty exciting. You think we can, let's end is winner. And we'll write this whole thing. I'm a little nervous. Are you a little nervous? Yeah, it's okay. It's okay to be a little nervous. There's a lot going on here. And could we be wrong? Oh yeah, for sure. Probably mistakes. You want to try and compile it once by hand? See, yeah. Before I do any more, I might just see if it'll compile. So escape : exclamation point G++. Now don't forget, in this case we need a -C because the horse has no main. So I won't ever be able to run it directly. I'm just going to see if I can build an object file. Mainly I'm just looking for syntax errors while I'm still here. So horse.cpp. All right. Oh my goodness, can you believe this? Syntax errors everywhere. Okay. So when you have a lot of errors, do you see how nervous I look? I don't look nervous. It doesn't really, and you may have seen some of these things. Yikes, we're done, right? No. Don't care how many errors you have, look at the first one. That's the only one you look at, is look at your very first error on the list, because some of the errors may be false positives. So the first error is terrifying. And here's the thing though, when you look at it and relax a little bit, it tells me so much. In horse.h, line 12, and position 5, Boolean does not name a type. Did you mean bool? Oh, yeah, I meant bool, not Boolean. Oh, that's easy. Okay, okay. There's a bunch of other errors, but I don't even care. Just solve that one. So now let's look at horse.h. And I can't believe I was that dumb. But there we go. Write that. Okay, okay. Let's try it again. All right, let's try and compile again. Okay, it's upset about some other things, but again, all we're concerned about is the very first error. And if the very first error is different, then we have made progress. Okay, let's see. Horse.cpp, I can't do an advance with no type. Oh, wow, I am so slow. Okay, do you see what I did? I did the same thing everywhere. So dumb. All right. I made the same mistake in several places, and that's because I was programming in another language earlier today that has different requirements. Here on the header, I said that advanced was going to be void, and in C++, you have to explicitly say it's void. Duh, George. Okay. Where are we? Insert. Oh, my goodness. I can't believe I'm that dumb. But here's the good news. I was consistently dumb. So that one should also be void. Now, it probably guessed on these void ones, but it was never going to guess on is winner because that's a bool. So it's bad enough to call it Boolean on one side, but I never even actually gave it a type on the other side. So here's the other reason I'm not worried about the number of errors. I had a bunch of errors, but they were essentially all the same error. Oh, that's crazy. So I'll write this. I'll write this too, just to make sure. And now let's try to recompile. What? That's crazy. Cray. And I see what I did. This is a mistake I've made many times. And when you see something this horrible, you're like, I should just stop programming now. I mean, flower arrangement sounds like a good career. No. I did the stupidest thing. And this is a mistake I've made a lot of times, which is why it doesn't bother me so much because I've made it so many times. Okay. I didn't even pay attention to what line it was. It was this line. Look at that. Standard cout. And then I meant to do standard endl, but my brain just typed cout. So change word to endl. Sometimes the most horrifying errors are the easiest ones to fix. And so how do you get to the point where you see that and you don't freak out? You get experience. That's how you do that. Okay, let's try and compile this again. Okay, it's still got problems. Oh, good grief, am I sloppy? I didn't specify horse num to be an int. That's on line 16, okay. Here's the good news. I could have missed all that, and I did, right? But when I try to compile and I get these syntax errors are not the enemy. Syntax errors are my friend because they remind me of mistakes that I made, and almost always they give me pretty good information that helps me get through them. So you can see something beautiful is happening, is that the number of errors is generally going down to nothing. Does this mean my program works? No, it doesn't. But it does mean that at least it compiles. So the syntax errors I have now cleaned up, and I'm feeling pretty good about my life right now. All right, so that's pretty good. Here's what we're going to do. Okay, we need to make a couple of changes here. For now, I'm going to go ahead and just say, hey, this is a breakthrough. So I'm going to git add everything, git commit -m add horse class. Okay, the fact that it's not actually running yet doesn't bother me too much, but I have made a breakthrough and I want to be able to come back to this point if something goes horribly wrong. All right, so that's great. Now what do we need to do? Well, now we need to modify the main function so that we can test the horse class. You don't want to even deal with race yet, right? We don't want to deal with the race class until we know that the horse class is doing what it's supposed to do. So the next step we're going to do is go to main and build what we call a test harness. And that's kind of cute because horses go in harnesses, right? So vim main, oh, no need to yap, main.cpp. Okay, and I'm going to change my main. Yeah, I'm interested. Okay, I'm going to change the main a little bit and have it do something different. I know what I'm going to do. I'm going to make a new function that I'm going to call test horse. And I'm going to literally put my horse through its paces. I'm going to change this line to test horse. Okay, and now end main, void test horse. And I can do this in a couple of ways, but the main thing I want to do is I want to write a little program that proves to me that I can build a horse and that it can do the things that it needs to do. So this is the most primitive form of what will become in your life a thing called test-driven design. So I'm going to see if I can make a horse and make it do what it needs to do. So horse H, okay, for int, I'm just going to do it this way for now. For int I gets 0, I is less than 15, I plus plus, oh, plus plus plus. Okay. So 15 times I'm going to do h dot advance. I'm building the horse right now on the stack, so I can do that. Advance, does it take anything? No. Horse advance, h dot print lane, and I think I need the length first is how I set it up. 15, horse number 1. This is not my final thing, but what I want to know right now is if I just advance it a few times and print the lane, will those two methods work? And what do we expect to see here? Well, what I'm hopeful is I'm going to see the horse moving across. It's not going to finish, probably, almost certainly not. But at least with 15 iterations, I should see it advancing sometimes and not advancing sometimes, and I should see it printing the lane. So that's going to give me a good way to test and see if things are working correctly. Now, because I now have some more complex stuff going on, I need to look back at my make file. That's become a little more complex. So vim makefile. Now let's think about the way this works. It's going to be a little bit different because now I'm going to run main as an object file and horse as an object file. So let's rethink this a little bit. My dependencies are going to be different here. Delete to the end. Oh. Just delete it. Okay. Oh, I was in insert mode. That's weird. Okay, and okay, so horse race is now going to be dependent on horse.o and main.o. And it's going to be a different set of commands, g++ -g horse.o main.o. Okay, because now I'm going to be, this final target is going to be linking, not compiling. And so that's going to put these guys together. Now we'll rethink main.o, that's a new target. Main.o is dependent on main.cpp and horse.h. So if the horse header files change, I'll definitely want to recompile main. Okay, and it's just g++. Tab, not space, g++ -g -c. -g means add the symbol table. -c means it's going to be an object file, main.cpp. Now I'll do horse.o. And that's dependent on horse.h and horse.cpp and its command is going to be g++ -g -c main.cpp. There are more efficient ways to do this, but this is fine. Okay, okay. I don't think these other things will change. So now let's try this. Okay, make clean, make run. Okay, okay, okay. Horse was not declared in this scope. Okay, okay, let's take a look. Oh, I think I know why. Look at main. It's trying to create a horse, but how does it know what a horse is? It doesn't. I never told it. Again, it seems like maybe I shouldn't freak out, right? So pound include horse.h. See, I was afraid I wasn't going to make mistakes. Okay, I think that's going to be good. Let's do another make run. It is useful, and now it complained again. Don't panic. It is useful to see that even when the code compiles correctly, that doesn't mean it necessarily runs correctly. No such file or directory, horse.o. That's interesting. Okay. Let me look at my make file. I don't see why that's complaining. Let's give it another shot. Maybe you saw something I didn't. See where it complains. Okay. No such file. Horse.o, main.o, horse race. Did I not have a dependency for that? Oh, duh. Look at that. I'm such a fool. You're allowed to call yourself a fool, but then you have to fix it and then say, I'm really a clever person. Yeah, maybe I should actually do horse.cpp. Yeah, what a goofball. Okay. Will that kind of stuff just kill you? Yeah, but look at how worried I got. Look what I did. I looked at the data it gave me. It told me clues, and I just had to follow the clues. And okay. Okay. Well, this worked, but it made a mistake. Well, I made a mistake. I don't think the horse number was supposed to change. I think I printed out the wrong thing. But I'm pretty close. I'm pretty close. So vim horse.cpp. I see a minor error. I shouldn't be printing out in print lane position. I should be printing out the horse. No, that's silly. Okay. Change word, horse. Aren't you glad that we only are looking at one thing at a time? It's just our life is so much easier now. Okay, so let's make run again. It should know what to recompile. And yay, that's exciting. Okay, before I go any farther with this, I want to check now and make sure that the isWinner is working. So this was an easy way to just test it and make sure it looks like it is sometimes moving forward and sometimes not. That's perfect. Now let's take a look at the isWinner because I haven't tested that. So vim main.cpp. We'll change this loop to something a little bit more like what we're going to have down the road. Okay. Bool, keep going while keep going. Now I might do something like this. If isWinner 15:1, that's the current horse is greater than or equal to 15, then we'll say keep going gets false. There are other clever ways to do this with Boolean algebra. If you understand that, that's great. If this is the easiest way for you to understand. I think this is going to be fine. So remember, is winner should be true or false. Again, I'm only testing one idea at a time. How do you solve a lot of problems at once? You don't. You solve one at a time. You take your big, difficult problem and you break it into a bunch of small problems and see if they work. So is winner is a Boolean function. It's going to return a Boolean value. So I don't even need to compare it to anything. I can just do this. All right, let's give that a shot. Oh, dear goodness. Okay. Okay. Are we freaking out? No, we are not. Well, keep going. Oh my goodness. See, the same advice I gave you before, right? You only look at the first error. I just forgot that in this language, you have to have parentheses around your conditions. And maybe that other stuff is real issues and maybe it's not. But I'm not worried. I'm solving the problem in front of me. That, and good grief, Harris, you need a squiggle brace. You don't have to be perfect. You have to be willing to listen to what the compiler is telling you. Okay, let's run it again. Good grief, is Whopper. Huh? Okay. Well, keep, oh, God grief. That's not a function. That is a variable. Okay. I don't know what is Whopper is. I think I need to use that somewhere. It is still complaining. Okay, if is winner, right? Because, okay, that's a legitimate issue. Is winner isn't a function. It's a method of the horse. Okay. Yeah. All right. I think we need to do one more thing here. And that is, let's test and make sure that it works if we create the horse on the heap. Yeah, that's okay. We can do it. Okay. All right. So, come on. My computer's dying here. There we go. All right. So now if we're going to do it on the heap, we're going to do it this way. No, not that. Horse pointer H gets new horse. Okay, the difference is now horse H is a pointer to a horse. The horse data is going to be on the heap. The pointer is going to stay on the stack. Now this has a couple of other small implications for us. One is we can no longer use the dot syntax. We'll use the dereferencing syntax. And the other thing is, because we created this inside the context of a function, that when the function is over, we need to delete H. So I don't expect there to be any visual changes to this at all. If all goes well, it should work exactly the same way. It's just now the horse data will be stored on the heap. Now I can't tell if there's a difference, so here would be a really good place to add a Valgrind target to my make file, just to be sure. So make file. We'll go ahead and add a Valgrind. Valgrind, that only matters when I have horserace compiled. And I'm going to do Valgrind -- leak check equal yes /horserace. I know it makes you nervous because all that happens at this point is I could make my life more miserable. But you know, you got to test for this because you don't want it to happen and you don't not know. So let's do a make val grind. Come on, baby. It'll run the whole thing. All heap blocks were freed. Oh yeah, baby, baby. All right, a piece of you is saying, you're kidding me. We've only got one class done and we've been at this for a while now. Right. But here's the deal. We're much more than halfway done because we have set up such a wonderful framework. And because the way that I've written this, almost all of the code belongs to the horse, not to the race. So it's actually going to be pretty good. So as soon as you find yourself dancing in your chair, what should you do next? Git add everything. Git commit -m horse class tested. All right, feeling good. Maybe I'll even upload it to my GitHub server at some point, but okay, I'm feeling real good about this. So now when we look back at our diagram, you can see, all right, I am fairly confident about this entire section. I feel like everything here is doing what it ought to do. Not only do I kind of know what it works, I'm pretty sure it all is working correctly. And this should just be easy peasy, lemon squeezy. That's what I'm hoping. I know I've also set up the framework. I've got my make file starting to work. I'm feeling good about compilation. And really the race itself is gonna be, I think, pretty easy. You think? I don't know. I'll see. This is where you get yourself in trouble as soon as you think, how hard could it be? Right? So let's do vim race.h. Okay, and I'm back thinking about header files, but you know how to do that, right? I'm looking at my diagram and it tells me a lot of what I need. There's not a lot of thinking here, it's a lot of boilerplate. So insert if and def race h exists, define race h. Yay, boilerplate. I like it. Okay, so the race is dependent on understanding the horse, right? So we're going to include local horse.h. I think that'll be useful. Now, this is just a class. Okay, and it has one protected data member. I'm not thinking here, right? I don't have to be thinking about, no, it has more than that, but I don't have to be thinking here. I'm just copying from my diagram. I did the thinking before I started coding. That's so wonderful. So I've got some protected data members. What we decided we were going to have was a horse pointer H. This is going to be an array of horses. The length I don't care since it'll go on the heap. I'm okay with that. Then I'm going to have a couple of constants, right? Const int length. Okay, and I think I can go ahead and just preset that as 15. Const int horses gets 5. And again, I could change either of those. That makes me happy. Okay. Public. Public is going to be my methods. I know I'm going to have a constructor. Okay, and I'm going to have a destructor because because I know that horse array is going to be on the heap. Good. And I'm going to have a start that's going to be void. Void start. That's going to do almost everything. I don't think I need any parameters on any of these. I think they're going to be pretty easy. So I'm going to end and race class. Okay, and I think that's all I need there. Let's do that same trick because that was pretty slick, wasn't it? V split. Okay. Race.cpp. And again, this is pretty straightforward. I know the starting place because every time I created a method on the .h file, I have to implement it in the .cpp. So that won't be that hard. I'm looking over. All right, so I need a race. Also, I should do some includes, right? So include first of all, my own header, race.h. I should also include horse.h. But doesn't race.h include horse.h? Be explicit. It's worth it. It's not going to hurt you. That's why we have those header guards in place. Okay, so that's good. Let me check something here. I'm a little nervous. Oh, sorry. Okay, I thought I had lost a line there. Okay. All right, so include race.h includes horse.h. I think everything should be fine. Now let's try and build something. Yeah. Let's do the constructor. Okay. Race, no parameters. There really isn't much to do except H gets new horse array with 5 elements. Okay, there's a lot going on in that little line, not 5. Horses. Okay, that is in this case a constant, so it's fine, but since it's going on the heap anyway, it could even be a variable. But that's nice. I really like knowing exactly what I'm doing. I don't want magic numbers like 15. I want num horses because that's the number of horses. And I think that's all we need to get that aggregation. Let's immediately, though, think about the destructor because it's not hard. Since we created H on the heap, we need to make sure we delete it. So we'll delete. Now, because this is an array, you have to use that version of the delete, H. I think that'll work just fine. We'll test it with Valgrind. But aren't you glad we already have that in place? And destructor. Now, the only other thing we've got is the start method, right? Void. See, I'm not making that mistake again. Okay, now the funny thing is when we tested our horse class, we already basically did this. So think again about your algorithm. For each, let's see, until we have a winner, okay, now we go for each horse, advance the horse, print a lane, check for win. Wow. That's actually pretty easy, isn't it? And here's the even better thing. We've already got all these things pretty much set up as methods. So I think it's going to be pretty easy. So we're going to do this. Bool keep going gets true. We'll make this our old friend while going. Okay, this looks like it's going to be a for loop, doesn't it? Okay. For int horse number gets 0, hn is less than, what do we say, num horses, hn plus plus, so this goes through every horse. So we'll do h sub hn. And because this is actually an array lookup, even though they're on the heap, you can use the ordinary dot syntax. I know that's a little confusing, but experiment and you'll be able to see. Okay, so advance, where am I typing stuff? Advance, the advance did not take parameters. How do I know that? Because I'm still looking at my diagram. I always have, if you don't have a second monitor, print out your diagram and tack it to the wall, because that's going to be the key to keeping yourself from going crazy. Okay, so h sub hn advance. Now print a lane, h sub hn print lane, and I need to know two pieces of information: the length, which is this constant, and the number of horses, and the horse number, which is HN. How did I know that? I'm looking at my diagram. Oh yeah, okay, so check for win. So if H sub HN is winner, doesn't really matter which one it is, right? Then it's already going to print stuff out, so I don't need to deal with that. I'm just going to say keep going. Yes, false. Thank goodness for good indentation, so I should be able to tell what's what. And if you just indent properly, and then when you create an end brace, you look and see what that's ending, and if it's the thing that if it's what you expected because of your indentation, you're good. Label it, and or that should be the while, and it is. And while, I love my functions to be so pretty like this at the end. And start. I think that could be all we need. Oh, you know what I want to do though? I think I do want to do one more thing is I do want to stop. That's not going to stop them at the end of a lap. Let's go ahead and do it like this and you'll see why that's a problem. It's not a huge problem. Right. Okay, I think I've written the header. I think I've written the race. I need to do a compilation, right? So let me show you another neat thing. Let's go to the make file. I could do this. I could go ahead and put in the race dependency. And let me show you another neat thing we could do. Race.o, race.cpp. Actually, I'm going to go in the order. Horse.h, race.h, race.cpp. So those are the three things. If they change, I want to recompile. G++ dash G dash C race.cpp. Okay, I have this dependency working, but it's not connected to the other ones yet, right? I got a lot going on, so I'm just going to W quit, make sure everything's saved. Now I can do this. I can do, if I just do a make, it'll still work fine, but it didn't ever compile that race.o because I never needed it. You can actually tell your make file to go to a particular target. And so it actually did what I said. So it compiled race.cpp. Now there's an error. No maximum function for call to horse.is winner. Really? What did I call the function? Okay, let's see. Let's see, what do we call it? All right. Is winner. Oh, length and horse num. Yeah, okay. Yeah, it was the right function. It was the wrong parameters. Okay, so what line? Yeah, okay, race.cpp line 23. That's telling me exactly what was wrong. You have to be confident enough to read those directions. Is winner, I wrote it to take two parameters, and I didn't give it any parameters. Pretty wonderful. And it compiles. I'll be doggone. We don't know if it runs. So git add dot git commit dash m race class. Okay, so now we need to test the race class, but here's the really fascinating thing. Testing the race class is going to be easy peasy because that's the whole game. That's all the game does, is it instantiates the race and it starts it. So Let's go to main. And now we'll also include race.h. Okay. Now, rather than main testing the horse, I love that, but I'm going to take it out for now because now I don't really want it to do that. If something goes wrong with the horse or I change it, I may still want that function around, but I don't think I really need it. I'm going to do race R. For now, I'll just create the race on the stack. Why not? Race R, R.start. And can you believe it? That's my entire thing. Create an instance of race called R and we'll start it. You're kidding me, right? Okay. I'm gonna change my make file because now main has more dependencies and so does horse race. All right. So horse race is going to depend on horse.o, main.o, and race.o. Okay, main.o depends on main.cpp, horse.h, and race.h. Horse does that, race does that. I think we're okay. Well, we'll see. I could have made a mistake, but I don't worry too much. It's been a while, so let's clean up make. Oh dear. Okay. Oh, yeah, you see this stupid mistake I made there? The class has a capital R, and I use the lowercase. Tilde in Vim changes the case of something. Okay, what did it not like? Undefined reference to race. Main doesn't know anything about races? Okay, let's take a look. Yeah, I don't know why I can't see that. Let's see what it's having trouble with. Race R start. That took in race.h. Let's see if it'll tell me more information. Okay. Main.cpp. It didn't know anything about the race, did it? Okay. Well, that's puzzling. Okay. Not sure where that's giving me troubles, but that's okay. So I'm glad you see me having a horrible mistake because you will too, and you'll get past it. Now, you're not going to be recording in front of people, so it's a little less intense. All right. I am not seeing any problem here. Race R. I'm going to try and compile things by hand just to see. G++ dash. Now let's take a look. ls. I do have race.o, horse.o, main.o. I actually think my mistake is in, yes it is in the make file, and it is. I said I'm depending on horse.o, race.o, and main.o, but I did not link all three of those files. So horse.o, main.o, race.o, dash o, horse race. Okay, that's better. So you see, it looked horrible, but it wasn't a terrible thing. I just got sloppy. You know, I knew when I saved this I was missing something. I couldn't figure out what it was. But yeah, it didn't know what race was because, well, I compiled it just fine. I forgot to link it. Not a problem. Okay, let's make clean. Run. Okay, that worked great. A couple of problems. One, I want the race on the heap. The other one is I'd like it to stop at every frame and give me a chance to move on. It's much more exciting when the user feels like they're at least watching it, right? So we'll go to main. I think that's where that was. And okay, let's change this. So after we've done, not there, but no, it's not there. I think it should be in race.start. That's fine. E race.cpp. Yeah, I think it should go right here. So after we've done all of the horses, so after the for loop, but before the end of the while loop, I want to see if I want to give the user a chance to press the enter key, right? So I'll do something like this. Where the heck are we? Right there. Standard cout, press enter to continue. This standard cn dot ignore. That we'll just clear the buffer and wait for the enter key. I think that's going to be great. Oh, no, no. Cn is not a member of standard. Yes, it is. You know why? You know why? Because in race, I hadn't done any input and output before. So I'll go ahead and do pound include standard io.h. And I'll actually give it the right braces. Nope, not standard IO, IO stream. And you don't have to do a .h when it's a built-in library. Oh, yeah. My money's on 0. Come on. Yep, 0-1. Of course, I waited till the race was almost over. Okay, one more thing I want to do is let's go back to main. Oops. Let's put race on, let's put this R on the heap. So, okay, I don't know why I did that. Okay, so race R gets new race, so that'll post, so it'll be race pointer R gets new race. Now I'll do R start, because I like to put classes on the heap. But now when main is over, I'll just delete R and get my memory back. I think I'm just about done, so let's do a make clean, make run. I don't expect any visual changes because the changes I made were in memory allocation. So unless I did a dumb syntax error, you won't really see it. I also never seeded the random number generator, so I'm going to get exactly the same winner every time, so we should really deal with that, but I'm going over. So now let's do the make val grind to make sure that I still don't have any errors. Now you have to go through the whole program because it won't know there's memory errors until you come back. No leaks are possible. And there you go. So I went from 0 with plenty of mistakes and plenty of human frailty, and went from 0 to a working copy of a program. That's the process. Okay, one more thing I should do, right? Git add dot git commit dash m tested race. And then git push dash u or whatever, push it up to wherever you want. That is how we do a project in C++. Pretty exciting, huh? All right, I know this was a longer video, but I think it was probably really helpful for you because this is the process that we're trying to do. So, all right, I will see you next time. Take care.